Welcome to PM Ready, your guide to becoming PMP certified. This is a lesson on executing, monitoring, and controlling schedule. In this lesson, we provide an introduction to earned value analysis. However, earned value analysis is rather involved, and it can take a while to really get a grip on it. And so there are separate lessons that dive into the details of earned value analysis, but in this lesson we'll introduce the basics. We'll also introduce the iteration Burndown chart, which is used in Agile processes, the practice of resource leveling and smoothing, as well as the schedule compression techniques of fast tracking and crashing. In this table, you can see that the control schedule process is the one and only monitoring and controlling process for schedule management. By this time, you'll have already gone through the planning schedule processes of plan schedule management, define activities, sequence activities, estimate activity durations, plus the estimate activity resources process from the resources knowledge area, and finally, the develop schedule process. With those processes behind you, you're now ready to execute, monitor, and control the schedule. You'll notice that there isn't an executing process listed here. This is just what we saw with scope management. No executing process. This is because the integration knowledge area process of direct and manage project work integrates the executing processes for scope, schedule, and cost management, and so it's not listed here. The control schedule process also needs to integrate with the monitor and control project work process that's in integration management. The main or primary outputs of the control schedule process are schedule forecasts and work performance information. As with most other processes, there are some secondary outputs as well, but for now, just hold on to these two. The control schedule process is similar to the control scope process. They both monitor the status of the project, they both manage changes to the baseline, and they both interface with and are even considered a part of the perform integrated change control process. Control schedule monitors the status of the project relative to the schedule in order to update the schedule as needed. The project manager, as part of this process, should proactively identify and attempt to influence those factors that affect the project schedule, including those that create schedule changes. This is similar to the project manager's responsibility to proactively manage the factors that can affect the requirements and scope of the project. The control schedule process is where you determine, based on the actuals data you have received from the direct and manage project work process, whether the project schedule has changed. As part of the control schedule process, you also review the project's schedule reserves and whether they're still sufficient, or whether they need to be increased, or perhaps even decreased later in the project when some significant schedule risks are behind you and have not occurred. Control schedule manages changes to the schedule baseline, but does this through change requests submitted to the perform integrated change control process. Now we come to the control schedule process's inputs. These begin with work performance data, which comes from the direct and manage project work process. This includes actuals data, particularly the actual start dates of activities, their current status, their degree of progress, and the estimated completion dates, and their actual finish dates. The actuals data is then compared to your baselines to determine your current schedule status and whether any changes have happened or are needed, as well as any needed corrective or preventive actions that should be taken. The project schedule and schedule data, along with the project calendars and resource calendars, are needed in order to update this information and propose changes. The schedule management plan will specify the frequency with which you should be reviewing this information and updating the schedule, as well as how schedule reserves may be used, and the rules for controlling the schedule. The Lessons Learned Register will include lessons learned earlier in the project that can now be applied to how you control the schedule, including the identification of root causes and how well corrective and preventive actions have worked. You should check to see what organizational process assets you have available to you that can help you to control the schedule. Specifically, policies, procedures, and guidelines related to controlling schedule, either formal or informal, including monitoring and reporting methods, and any schedule control tools. In particular, take a look at your scheduling software to see if it includes the control tools that you need. For tools and techniques, the control schedule process has several in the category of data analysis. These include earned value analysis, performance reviews in which you compare actual data about schedule performance to the baseline, variance analysis in which you check for variances on starting and end dates, activity durations, float between activities, investigate the causes of variances, and assess the impacts on the overall schedule. Trend analysis is when you graph the performance over time. The iteration burn chart, which shows the remaining work to be done in an iteration. And what-if scenario analysis, in which you experiment with different scenarios and how they can affect your project schedule. Earned value analysis is applicable to controlling not only your scope and your schedule, but also your cost. In the context of controlling schedule, there are three main variables of interest. The first is PV, which stands for planned value. This is the measure of how much was budgeted for the work done so far, and this is measured in dollars. Schedule variance, or SV, which measures how far off schedule you are, also measured in terms of currency. And SPI, or the Schedule Performance Index, which also measures how far off schedule you are, but measures it as a ratio or a percentage. Using these measurements, you can determine how far your schedule is swinging out of control or whether it is in control. To measure PV, or planned value, start by asking yourself what work packages were planned to be done by now, by this point in the project. And then assess how much you had budgeted for that amount of work that you had planned to finish by now. Keep in mind, this is not a measure of what has been done, but what was planned to be done. So it's a measure of the budgeted value of the work that was planned to be done by now. For example, suppose you're working on a 10-month project that has a total project cost of $1 million, and that you're expected to spend, just to keep it simple, $100,000 per month. That means at the end of, say, a month, your planned value is $100,000. After 2 months, it's $200,000, and so on, regardless of how much you're actually spending on the project or how much you're actually getting done. That's the plan. So that's your planned value per month. Now we need to introduce another variable, and that is earned value, or EV. To determine earned value, you ask yourself what work packages have been completed so far, what's actually been done. And then ask yourself how much was budgeted to be spent for the work that you've completed so far. Not how much have you spent, but how much had you planned to spend for what has been done so far. For example, considering our previous project that spends $100,000 per month, or that had planned to spend $100,000 per month, let's suppose that after 2 months, you've actually completed 3 months worth of work, so you're ahead of schedule. That means that your planned value is $200,000 because that's what you had planned to spend on the work so far. But your earned value is $300,000 because that's the budgeted amount of what you've actually completed, but not how much you've actually spent. That's an important distinction. Now we can calculate schedule variance, which is your earned value minus your planned value. It's the difference between what's been done and what was planned to be done by now, measured in terms of money, not time. In our example here, we have an earned value of $300,000 because that's how much we had budgeted to spend on the work that's been done so far, minus $200,000 because we'd only planned on completing $200,000 worth of work, which means our schedule variance is a positive $100,000, indicating that we are ahead of schedule. The schedule performance index is almost the same. It's earned value, but this time divided by planned value rather than subtracting planned value. Also measured in terms of money, not time, but the money factors out when you do the division. In our example, you take the $300,000 of earned value, divide by the $200,000 of planned value, and you end up with a ratio of 1.5, which is a measure of how far ahead of schedule we are. Just as any schedule variance greater than 0 is an indicator that we're ahead of schedule, for the schedule performance index, any measurement greater than 1 indicates that we're ahead of schedule. Now we can use this information to forecast when the project will be completed. We can take the original project duration and divide that by the schedule performance index. In this case, the original plan was for 10 months. Divide that by the 1.5 schedule performance index, and it tells us that we are forecasted to finish this project in just a little less than 7 months. Now there's another newer way to measure this schedule variance, and that is using earned schedule, or ES. This time, this is measured in time rather than in money, which makes a little bit more intuitive sense. But we'll need to introduce a few new concepts here. PD is planned duration, or the original project duration, and EAC is the estimate at completion. EAC, in terms of earned schedule, is the planned duration divided by the schedule performance index, which is what we just did on the previous slide. However, this time let's do it in terms of time. In our example, our earned schedule is 3 months because that's how much work we've completed so far in just 2 months. So our schedule variance in terms of time is our earned schedule minus our planned duration, which is 3 months minus 2 months, which equals 1 month. Our estimate at completion is 10 months divided by the schedule performance index, which is 10 months divided by 1.5, which gives us the 6.7 months. Instead of showing how much work has been done, the iteration burndown chart shows the opposite. how much work is remaining to be done in the current iteration. And it graphs this against the plan, and can include a line that forecasts the remaining work based on performance so far in the iteration. Other tools and techniques include the critical path method, which you can use to keep an eye on the critical path, as well as near critical paths that present risk, resource optimization, adjusting leads and lags on activities, schedule compression techniques, and your project management information systems scheduling software. Resource leveling is when you have a resource that is overallocated, and you reallocate their assignments so that they're not overallocated. And depending on other scheduling constraints, this reallocation can extend the end date. Resource smoothing is a little bit different. In this case, you want to even out your resource utilization, but you limit yourself to what you can do without extending the end date. Two types of schedule compression are fast tracking and crashing. Fast tracking is when you overlap activities in order to get things done sooner, but at higher risk due to delays in one activity that could affect subsequent activities, or changes that cause unnecessary rework in subsequent activities. Crashing is when you add more resources to get things done sooner, but at higher cost, because, for example, doubling the resources often doesn't cut the time in half, so overall costs go up. The primary outputs of the control schedule process are schedule forecasts and work performance information supporting the forecasts. You'll often update the schedule data, basis of schedule estimates, and resource calendars to reflect actual performance. You may also find that you need to make some changes to the baselines, which will require change requests that will go through your Perform Integrated Change Control process. And you'll update the assumption log, risk register, and lessons learned register as needed. Now it's time to quiz yourself on how much you remember of the inputs, outputs, tools, and techniques of the control schedule process. The main outputs are the schedule forecasts and the work performance information to support it. You will also update documents such as the schedule, as well as other baselines that require you to issue change requests. The inputs, well, since work performance information is an output, work performance data must be an input, and this comes to you from the direct and manage project work, which is part of integration management. You'll also draw upon all sorts of other documents and components of the project management plan. The tools and techniques include several data analysis tools, including earned value analysis, the iteration burndown chart, performance reviews, trend analysis, variance analysis, and what-if scenario analysis. Also the critical path method, your project management information system and its scheduling tools, resource optimization, adjusting leads and lags, and schedule compression. The most significant Agile practice related to scheduling is the sprint, which is typically an iteration of 2 to 4 weeks. The project scope is represented in a prioritized backlog of work packages and activities, and each sprint begins with a sprint planning session that selects items from the backlog to be worked on in the sprint. Other Agile contributions to schedule management include on-demand scheduling, exemplified by a Kanban or sprint board of items to do, items which are moved from the doing section when they are being worked on and into the done section when they are complete. This is an example of a pull system in which team members pull work from the to-do section when they're ready for the next item. A concept that is also often incorporated into this approach is to limit the number of work in progress items. For example, you may specify that each team member can only have one item in the doing section at a time. If they want to put something on hold, then they need to move it back to to-do, which may be an indication to you that tasks need to be divided into smaller pieces. This lesson has provided an initial look at earned value analysis, at least those components that are applicable to the schedule, and covered the iteration burndown chart commonly used in Agile approaches. Resource leveling, which can change the critical path and extend the final completion date of the project. Resource smoothing, which is limited to not extending the end date. Schedule compression techniques, including fast tracking by overlapping tasks and increasing risk. And crashing by adding more resources and increasing costs. As well as Agile approaches that use backlogs, sprints, and on-demand or Kanban techniques to manage the work. For more information, you can consult these pages of the PMBOK guide. PM Ready is a publication of PM Guaranteed and is based on the Project Management Institute's PMBOK guide.